Here's how to solve a radical equation. Recall that a radical equation is an equation that contains radicals with variables in the radicand. So what that means is that you have a square root sign, and underneath the square root sign somewhere there's going to be a variable like x. Our steps for doing this are to first isolate the radical. In other words, we want the radical all by itself on one side of the equal sign. So if there's a radical plus or minus a number, we need to move that number to the other side. Second step is to square both sides. This will get rid of the radical sign. And then from there we solve our equation, and the most important step is you need to check. You must check every radical equation that you solve, because sometimes you can end up with answers that don't work. Let's take a look at some examples. Our first example is the square root of x minus 3 plus 8 equals 15. So the first thing I need to do is isolate my radical by subtracting 8 from both sides. So I get the square root of x minus 3 equals 7. Now I'm going to square both sides. When I square the square root of x minus 3, I get just x minus 3. And when I square 7, I get 49. Now I have a very straightforward equation to solve. I'll add 3 to each side, and I end up with the answer x equals 52. I need to check this. Recall that to check an equation, you plug your answer, in this case 52, back into the original equation for x. So is the square root of 52 minus 3 plus 8 equal to 15? Now what I need to do is PEMDAS each side. Is the square root of 49 plus 8 equal to 15? Is 7 plus 8 equal to 15? Indeed it is. So my solution checks. So my answer is x equals 52. Let's take a look at a second example. The square root of 2x plus 3 equals x. My radical is already isolated. There's nothing being added on the left-hand side to my radical, so I square both sides. When I square the left-hand side, I get 2x plus 3, and when I square the right-hand side, I get x squared. Notice that my equation now has an x squared in it. That means that this is a quadratic equation. So I need to set this equal to 0. And so I'm going to subtract 2x and subtract 3 from both sides. So now I have 0 equals x squared minus 2x minus 3. I think it's always preferable to keep your x squared term positive. Now my quadratic on the right-hand side can be factored into x minus 3 and x plus 1. And remember, the way to solve this is if x plus 3 times x minus 1 equals 0, then one or both of those is going to equal 0. So x minus 3 equals 0, so x equals 3. And x plus 1 equals 0, so x equals negative 1. Since I came up with two answers, I do have to check each one of those. So let's start by plugging 3 into my original equation. Is the square root of 2 times 3 plus 3 equal to 3? Is the square root of 6 plus 3 equal to 3? Is the square root of 9 equal to 3? Indeed it is. 3 equals 3. So that answer checks. So one of my answers is x equals 3. Now let's try our second answer, x equals negative 1. And plug in negative 1 for x. So is the square root of 2 times negative 1 plus 3 equal to negative 1? Is the square root of negative 2 plus 3 equal to negative 1? Is the square root of 1 equal to negative 1? No, it is not. 1 is not equal to negative 1. So x equals negative 1 as an answer does not work. So this radical equation has only one answer, x equals 3. And let's take a look at a last example here. The square root of x plus 5 equals x plus 3. When I square both sides, I get x plus 5 equals the quantity x plus 3 squared. So that means x plus 5 equals, and don't forget this means x plus 3 times x plus 3, so that has to be FOILed, and I'll get x squared plus 6x plus 9. And again, I have a quadratic equation because I have an x squared in my answer, so I'll subtract x and subtract 5 in order to make this equal to 0. Now I have 0 equals x squared plus 5x plus 4. The right-hand side factors into x plus 1 and x plus 4. Setting each of those factors equal to 0, I get x equals negative 1 and x equals 4. And again, I must check each one of those. So starting with negative 1, remember we're going to plug negative 1 into our original equation for x. Is the square root of negative 1 plus 5 equal to negative 1 plus 3? Is the square root of 4 equal to 2? Yes, 2 equals 2. That answer checks, so one of my solutions is x equals negative 1. Now we need to check our second solution, x equals negative 4. And let's plug that into our original equation for x. Is the square root of negative 4 plus 5 equal to negative 4 plus 3? Is the square root of 1 equal to negative 1? No, it is not. The square root of 1 is 1, and 1 is not equal to negative 1, so x minus 4 does not work, so my equation has only one answer, x equals negative 1.